All right, you are welcome to start.
Alrighty, well, thanks for coming, y'all. My name is Catherine Payne. I'm an associate professor in the math department, and I'm gonna just show you a little bit of a problem-solving assignment that I made up as we've been working on this problem-solving rubric and trying to decide what that means. So I'll talk you through a little bit of kind of what the assignment is and how I use it. I'll show you what it looks like. It's not complicated. Um, and then you can ask me whatever questions you want to ask. So I've got a couple of slides. Let me get the right file here and we'll see how things are going. All right, can you see my slides?
Yes.
Excellent. So I am a math professor, so obviously the things that I make are math. So I'll tell you a little bit about what's in the problem solving rubric and which pieces this hits on and which pieces it doesn't, and then I'll show you the assignment. The rubric has five main, I'm losing the word, categories. The first one is to define a problem, and we set up various assorted criteria for how you get from a benchmark to a milestone to mastering that. And then proposing solutions or hypotheses, evaluating potential solutions, implementing a solution, and then evaluating outcomes. And I am not going to hit all five of them, but I am going to hit four of them. So just a little context of how this is going to work. The activity I'm doing is intended for a Calculus 1 class, and it's typically completed around week 11 or 12 out of a normal 15 or 16 week semester. So it's about 2/3 of the way through, maybe 3/4, depending on how fast we go. And it's at the end of a chapter on what we call optimization problems, which are basically about finding the largest or smallest whatever it is that you're interested in. So sometimes we do area, we want the largest area. Sometimes we do price, we want the smallest cost of doing something. There's lots of different contexts that could go here. When I do this assignment, because this is not brand new, this is something I already had and tweaked for this. It's begun in class because students typically have lots of questions. But once they get started and they know the process, then they complete it for homework and I take it up as a quiz grade. So here's what we hit. I asked them to define a problem. I asked them to propose solutions. I don't ask them to evaluate potential solutions because I'm usually doing really good to get my students to propose one potential solution. And they're not very likely in this particular setup to have multiple potential solutions to think about. Once they've done that, they have to implement it and then they have to evaluate whatever kind of answer they get. So the way it works is I give them two sort of scenarios and they get to pick which one they want to work with, but they're going to do the same things no matter which scenario they pick. So the two scenarios that they have to choose from, one of them is about designing jewelry boxes, and they have the square base and an open top. So it's basically just an open top box. And they get some information about how much the material cost to make the different pieces of the box. And they have to decide what's the biggest box they can make within a certain budget. The other option is about running a power line from somewhere on the beach to somewhere out in the ocean. And they have to decide what's the best way to run it for the cheapest cost, because it's cheaper to run the line along the land than it is to run it under the water. Obviously, you have to run it under the water some to get it to someplace out in the ocean. But how do you set that up? How far should it go along the land? How far should it go underwater in order to have the smallest possible cost? So they get to pick one. If anybody's feeling super fancy and they want to do both, I'm not going to turn them down, but that never happens. They pick one of these problems to work on, and they're kind of dealing with the same type of material that I want them to practice. So here's what I asked them to do with whichever problem they decide to work on. They have to describe the problem in their own words. which is what I'm saying is part of defining the problem. If they can read what I've given them, but they can't say it back to me, then they don't really know what the problem is. And so if they can repeat it back to me in their own words, then I know that they're getting a handle on what the problem is that we're trying to deal with. In a perfect world, I would make this more open-ended and let them do more of defining the problem. But in the context of a calculus class, where the focus is really on the process for getting from the problem to the solution, that's a little harder to do. So I'm not going there with this particular group of students. Once they've done that, I ask them to estimate some possible solutions. That comes in the format of, tell me what do you think is the smallest and the biggest reasonable cost for this? Just to get them thinking about what is this in real life and what are reasonable answers going to look like. So that's one part of a potential solution. Give me some reasonable guesses. And then the next part is also part of a potential solution. I'm asking them to plan the steps to approach the problem. And that's something that they struggle with a lot. You hand students a math problem and they tend to just start scribbling numbers down into whatever formula you taught them most recently and kind of hope that that number goes where they put it and it's going to give them the right answer. And so this is something I've really been working on to get students to think through the process of how they're going to do this. I'm going to try to find this value, or I'm going to work on this formula, and make a plan before they start doing anything. Once they've got a plan, then they're going to need to write some kind of an equation to model their situation. That's in math speak, that's part of defining the problem. You can't solve the problem until you turn it into an equation. And that's something that they work on a lot in class. Once they've got all that, then they can implement their plan. That's where they actually do whatever they said they were going to do. And then once they have an answer, I'm asking them to evaluate their answer in the context of the problem, which means I ask them some questions like, is it reasonable? What does it mean? Write me a sentence describing what your answer said. Tell me, how does this answer make sense within the problem? Or if it doesn't make sense, then tell me why it doesn't make sense and what you think went wrong. Anything like that is good. I just want them to get in the habit of taking the answer and doing a sort of reasonable check. Does this make sense? So that's the last piece I'm asking them for. So what I give to students is really just a piece of paper that looks like this. I had a zoom in button, but I lost it. Sorry, y'all. Let me. Dang it. Let me switch screens and I'll show you the assignment in something you can actually read. There we go. So when I give it to students, it just looks like, here's the two scenarios I showed you up at the top. I tell them to pick one of them, and then I give them steps. By the time they got through a bunch of problem-solving classes, I would hope that these steps are kind of second nature and I don't need to tell them. But in Calculus 1, these steps are probably not second nature, and the only way I'm going to get them to do the things that I'm interested in evaluating through our problem-solving rubric is to explicitly make it a part of the assignment to say, describe this problem in your words. Give me a guess at a solution. Plan your approach. Write an equation. If I don't say those things, then students are not going to do them at the point that I'm working on. Maybe they would later. I would love that. But at this point, whatever I want to evaluate out of our problem solving rubric, I have to specifically ask students to do to have any hope of having something to evaluate. And so it just goes through exactly what I told you. And for me, I evaluate this kind of assignment with the rubric to turn in data. That does not usually bear any resemblance to the grade that I'm going to give my student in Canvas. Because in Canvas, the part I'm really interested in is the implement your plan, show all of your steps, show your calculations. But they get some points for doing the other parts, and it gives me enough things to evaluate with our problem solving rubric. So switching back. That's the bulk of what I've got. I'm happy to go back and revisit anything and see what kinds of questions we've got. I just wanted to show you a little bit of what I would do if I needed a problem solving assignment.
Floor is open. Any questions for Dr. Payne?
Dr. Payne, Ken Brown here. Thank you for sharing this with us. I have a question in regards to how you score it against the rubric.
Okay.
Is there a rubric like for each of those components that you expect students to have this part, this part, this part, this part? And I guess more broadly, is this done in all the sections of Calc 1 or is it just done in your section? Does everybody have their own?
There's only one section of Calc 1 and it's mine.
Okay, easy enough.
So there's that.
Gotcha.
In terms of how I would evaluate it against the rubric, I've got the problem solving rubric open. So let me get that one over here and I'll say a little bit about what that would look like. Where'd it go? There it is. So, the first part about defining the problem, right? The way we worded it in the rubric is about how the student constructs a problem statement with evidence of contextual factors. And so what I'm asking students to do is to take kind of a scenario and say what the problem is in their own words. So I would be looking for things like, do they mention all the important information in their own words? Do they leave out anything that's sort of essential? Do they say it clearly? Are they still kind of fuzzy on exactly what the problem is that they're trying to solve? And that would help me to line up with this rubric of milestone 2, milestone 3, capstone, benchmark is back over here, right over here. Does that kind of help?
Yeah, thank you.
Sure. The only thing I would add to that is that as I made those steps that I asked students to do, I was really clear about mapping them to which part of the rubric that I want that question to go with. So I know that there's 2 steps that I asked them to do about writing the problem in their own words and then writing an equation that I'm going with for define problem. And then there's, I think, estimating and making a plan that I'm putting with solutions and hypotheses. So it's very like this piece of the work goes with this piece of the rubric.
Any other questions?
I guess I have another one, just thinking more broadly about the SLOs. I think the future plan is to have different levels of each of the outcomes so that students are getting introduced to it, reinforced, and then we're trying to decide or evaluate them at a mastery level. Do you see this class as kind of like, or this project in this class is in the middle? I would assume they've had some problem solving course before Calculus 1.
Well, so that's an interesting question, given that, so context, right? When I signed up for this problem solving committee, math was debating between problem solving and data fluency were our 2 kind of, these make sense for us. And then the decision was made that at least the introductory level classes are all going data fluency because there's the requirement that one of the data fluency classes has to be math. Calculus 1 is kind of on the border there. They've had some math before this, but it's conceivable, depending on their high school and their background, that somebody could come from high school and take Calc 1 as their first math class. So I'm seeing this as beginning to middle of this process, depending on the student and where they come from.
I was just curious. I was just sort of thinking how it would fit together. Thank you.
Okay, anyone else?
I'll just toss out there that this thing is not a new assignment. This is an assignment that we were already doing that I added some steps to so that I could evaluate all the problem solving pieces. This is not, I created something brand new that was never in my class before.
All right, if there are no further questions, thank you, Dr. Payne, for talking us through one of the assignments in your course. Thank you, everyone else, for joining us today, and be on the lookout for another problem-solving workshop next month. And our guest facilitator will be Professor Cynthia Villagomez, who will be sharing from her perspective from the history department. Okay, thank you all for joining, and have a great day.
Thank you.